And where is that? Outside of the ear, where else?
Nose.
What? No, that's still a highlight. Epiglottis. Epiglottis is elastic cartilage. You're not gonna hold two bones together with elastic cartilage, it's gonna tear. So you don't use it for that. But who up here could you use? Hyaline cartilage, does it look like what you saw the other day? Yeah? And where was this hyaline cartilage you saw? In the trachea, the rings. The rings of the trachea are open in the posteriorly. For what reason? They're shaped more like horseshoes than round rings. Esophagus is behind there. Remember, you had esophagus and trachea on the same slide. So I was glad that they made slides with both on it because they're both there together. So these are little chondrocytes in their lacunae. That's right. And in their case, they can have roommates. Okay. In the osteons, you just have no. In the osteons, the onion rings have lacunae too, but they only have one osteocyte in each one. Okay. So this cartilage came from ribs, so you call it costal cartilage. Hyaline costal cartilage. Yep. Okay, so they're different. Oh, these cells are lacunae are surrounded by matrix. Matrix equals ground substance plus fibers. And the fibers may be hidden, you don't see them. So fibers plus ground substance equals matrix, and matrix is out around the chondrocytes, but they're not part of the matrix. Okay? Come over here. Doesn't this look like elastic on some kind of garment? Yeah. So these are elastic fibers in there, but what are we talking about? We're talking about the largest artery in the body, aorta. And so it's under a lot of pressure. How much pressure? Well, if the aorta broke, blood spurts out 5 feet in the air. That's a lot of pressure. Okay? So the heart is beating and the aorta is going boing, boing, boing. Well, it needs to have elastic fibers, so it does. So that was elastic connective tissue in the wall of the aorta.
Is it the interior or exterior?
The lumen is probably right here. Yes. To stretch it? Okay. In an auction, you could have bought something just like that. Okay. Now I want to know, this is connective tissue down here. Is this dense?
No.
You don't think that's dense? Is it regular?
No.
No, it's irregular and it is dense. Okay? So this is dense, irregular, connective tissue proper. Okay? Dense, irregular, connective tissue proper. All right. If it's irregular like this and you pull on it, it's actually strong in all directions. And see, you can use that as a fibrous joint capsule. It would work for that.
Did you say the name of it?
Dense, irregular, connective tissue proper. They don't put proper on, but I do. There's a whole category of proper, so we're getting ready to look at that. So let's move over here. Is this dense?
Yes.
Yes. Is it irregular? No, it's regular. So this is dense, regular, connective tissue proper. So tendons, did you see tendons in the chicken?
Yes.
Yeah? And ligaments, we tried, but we didn't really see a good example of a ligament. But this could be a ligament. This could be a tendon. And so it's dense, regular connective tissue proper. Now, are tendons and ligaments pretty strong? Yeah. So if you pull on them right, they're strong. But if you went to the side and tried to pull this, what would happen? it would shred. It would shred. So it's strong the right way, but it will shred the other way. How about this one down here? If you pull on it any direction, should it shred?
No.
No. So this is tough stuff, okay? Your lower layer of the dermis is like this.
Do you think it's because of the way like the collagen fibers are arranged?
It's all of that put together. So the lower layer of the dermis is called what? No, that's, it's reticular layer of the dermis. What percent?
85?
80%. And then the upper layer of the dermis is papillary layer. What percent is that? 20%. Okay, that was different. But the lower layer was this, irregular, dense, irregular connective tissue. So we'll pretend we have a cow here. If you got the reticular layer of the dermis of the cowhide, what did you make? Leather. And you know what leather's like, your bucket seats or your coat or your shoes, you know what leather's like. It's tough in all different directions when you pull because it's dense, irregular connective tissue. You wouldn't make it from a tendon. That would shred if you pull the wrong way. Okay, let's go on up here. This looks interesting. They stain for these fibers, or you wouldn't see them. They stain the fibers, and these are reticular fibers, which we don't see loads of reticular fibers unless you're looking at the spleen, which is part of your lymph system and your immune system, and the spleen is often nicknamed what? Red blood cell. Graveyard, that's it. Red blood cell graveyard. So in here we've got reticular fibers, and these bluish ones are white blood cells, lymphocytes. Remember that was the second most common? What was most common? Neutrophils, okay? But what do you expect to find a lot of in the spleen? Red blood cells that are wearing out. So a lot of these may be worn out red blood cells. Let's look at this.
One question regarding
Yes.
the last slide. How do the red blood cells know when it's time to go?
Well, they're gonna go wherever they're pumped, but I think it's as they're coming through, they get grabbed. There are macrophages that can work on them. So I think they get selected out.
Got it.
And it may be that they kind of get lodged into some of the layers there. They only live for how long on average?
180.
120 days. 120 days. Doesn't this look a little bit like honeycomb? I'll answer it for you, yes, it does, okay? But these are not empty cells. They look like they are, maybe they are now, but they used to have a drop of oil in them. What kind of cells are these?
Adipocytes.
Adipocytes, fat cells, adipocytes. So places with a lot of fat, which would be under the skin, the hypodermis has quite a bit of fat. And this is showing the breast, the human breast has a lot of fat. That's not the only place, of course. And so if you were slicing it, is this dense or loose? It's loose, adipose, connective tissue proper. Right. So we have loose stuff and we have dense stuff. And here up here, we have the most common loose, this is loose, this is a realer connective tissue. So it's loose, it's not dense, it's loose, a realer connective tissue proper. And you have most of it. This is what you mostly have, okay? It sits underneath epithelium. So if you think about your digestive tract, you would have the esophagus, you would have the small intestine, and the epithelium, the lining of that sits on this, and it's called lamina propria. Lamina propria is loose, areolar, connective tissue proper underneath the epithelium. Look at this, we can see some fibers. These are real clear because they're dark, elastic fibers. Now what you may not at first see are, there are pink things running through here that are wider than that, and they are collagen fibers. Like there's a collagen fiber, there's a collagen fiber. These elastic fibers are much narrower. And what they don't show you are reticular fibers, because there are sometimes, they didn't get it in this picture. And these little black things are nuclei of cells, and it's harder to see what the cells look like. So what they did was, they made a drawing. So there you go, with what you're supposed to be looking at back there. Okay, are we looking at fat cells? Yes, those are, well, how would you label them? Adipocytes. Are we looking at capillaries? Yeah. Are we looking at these thingies, which I'm looking for a label here. There it is. This is an elastic fiber in this picture. Elastic fiber. This is a collagen fiber. See how it was there? On the other picture, it was the actual picture. It was light pinkish. Okay, so you have elastic fiber, you have collagen fiber, and they even show a reticular fiber. I think right there. No, maybe this. It's the blue. It's the blue. So they tried to show you what's there. Who's this climbing around? Macrophage. Macrophages develop from monocytes. The third most common white blood cells, monocytes. They're bigger, they change into macrophages. See this cell here, climbing around through the branches? That's a fibroblast. Do you know how it made these fibers? This is interesting. It spits the stuff out. I don't know if it spits, but it puts the stuff out there, and it self-assembles. These fibers self-assemble. That's pretty good, isn't it?
So it just
Releases it, and then it naturally unfolds. So nobody's in there with nails and hammers and pounding it in place. It just naturally comes when these things release the substance. It happens. There's your neutrophil. There's a lymphocyte. So they showed a couple of those.
Are macrophages the only ones that have like that
That arrangement.
amoeba looking?
Yeah, if
image and-
you see it crawling around, it's probably a macrophage. Now, the neutrophils are phagocytic also. They will eat debris and fight infection. In fact, they get to the infections faster than the macrophages do. The neutrophils will get there start getting there in about an hour. That's pretty fast.
They're like the alarm system.
They put up a real fight. They do, but they're weaker. So they take a lot of casualties. And you know what it's called? Dead neutrophils, what they're called? Pus. That's how you use pus, okay? And it takes about, I think it's 12 hours for the macrophages to start getting there, but they get there as monocytes, but then go into a red booth, how's that? Red phone booth, yeah, in a red phone booth, and they come out super fighters that come out of macrophages. Okay.
And now the fibroblasts, they are.
They're building the fibers.
The collagen part, all of them?
Uh-huh.
Elastic fibers?
I think so.
What do you say about the phone booth? They call it
The phone booth, yeah. Monocytes go into a phone booth, they come out Superman, they come out macrophages.
Did you go over what the mast cell does?
Mast cells release histamine. That's what makes your nose run when you get into allergies and stuff. Okay, so let's go back to, well, wherever it is. We've got a chart here we want to look at. And let's find it. There we go. Right there it is. That chart is on page 127. 127. So what is this chart showing you? It's showing you connective tissue. Connective tissue. So connective tissue could be connective tissue proper. So this is where connective tissue proper gets sorted out for us. We have loose connective tissue proper, we have dense connective tissue proper, and 3 kinds of each. The most common kind of connective tissue proper is loose areolar connective tissue proper. You also have loose adipose connective tissue proper. And in like the spleen and other places, you have loose reticular connective tissue proper. So those are your loose ones. And the most common connective tissue proper is areolar. Then the dense ones, a dense connective tissue proper, you have regular dense connective tissue proper, you have irregular dense connective tissue proper. Which one of those is your lower layer of the dermis? Irregular, right. And the upper layer? No? No? The upper one is the areolar. You're up there with the papillae of the epidermis. Well, it's dermis, papillae that makes the epidermis go up and down too. Okay, and then we have dense elastic connective tissue. But we don't talk a lot about that. These two are important because which one is used to make leather?
The irregular.
Irregular one, dense, irregular connective tissue proper. Okay, then you have connective tissue that's not proper, like cartilage. Is that connective tissue? Yeah, it certainly is. What kinds do we have? Hyaline connective, hyaline cartilage, elastic cartilage, like in the ear or the epiglottis, and fibrocartilage, like in the disc, in the spine, and also the pubic symphysis, stuff like that. And then we have bone tissue. This, people get into trouble with this. Bone tissue could be either compact or spongy, depending on what's in there. If it's osteons, it has to be compact. If it's trabeculae, it has to be spongy. And bone, and you say, well, isn't that one kind of connective tissue? Well, it is, or it is connective tissue, okay? But these are all connective tissue, but it's not connective tissue proper, right? And blood, now they decided to call that connective tissue, just like I told you, because it comes from the same stuff that the other connective tissue comes from, embryologically. So they decided to put it there. They had to put it into some category, they thought. So there's more stuff here we're gonna skip over today, because we want to go to the last grouping that we want to talk about in chapter 4. So I'm going here to page 118. On page 118, we have epithelial cells. Epithelial cells. They come in some different shapes and varieties. Like you have the pancake cells, the ones that look like a pancake, or from the side looks like a fried egg. And the nucleus is the yolk in there. So that's called a squamous epithelial cell. Squamous pancake cells. And they could come as little cube-like things, cuboidal epithelial cells. Or they could come as columnar ones, columnar epithelial cells. Now look at the nucleus. If the nucleus is down towards the bottom, think columnar. If the nucleus is more towards the center, think cuboidal. So if you have to decide, that can kind of help you decide in some more difficult cases. Could you have a single layer of epithelial cells? Yeah, like this. This is a single layer of pancake cells, squamous epithelial cells, okay? And there are surfaces here. Underneath is the bottom surface, it's basal surface. On top is the apex, apical surface. Okay? So here, we had to go with a lot of cells, a lot of cells, epithelial cells. So this is stratified. stratified, layers. So like, if you drive up in Smoky Mountain National Park, or Kentucky, or some of those other areas, where they cut through for the road, you can see layers of rock. You can see coal sometimes, layers of coal in those areas. We call those strata, rock layers, strata. So this is got a lot of layers, so this is stratified. Stratified epithelial cells, stratified epithelium. This was not stratified, so this is simple epithelial layer.
Is simple only if it's a single layer?
If it's a single layer, yeah. If it's multiple layers, it's stratified. Usually multiple layers too, okay? And we've looked at this. If you're not sure if it's columnar or cuboidal, check out where the nucleus is. Cuboidal should be more towards the center, and the columnar should be more towards the bottom. They're not perfect here, but that's what they are. And the nucleus here in the squamous one is like your fried egg look. Okay? Now, we're going to look at the one on the next page here. And this can almost be an optical illusion. Okay? You remember looking at magazines, kids' magazines and stuff like that in the past, where they would have optical illusions and you get fascinated by, which is it, a woman or the hat? What is it? Okay, well here, I've got a question for you. Is this a jigsaw puzzle, pieces put together, or is this a string in the air? What do you think?
Jigsaw.
It could be jigsaw puzzle pieces put together, or it could be stringy stuff in the air, suspended. What do you think? It's gonna help you probably if you know where you are. So here you are, in the lungs. So you got a lot of space, a lot of air space. These are stringy strands in the air. So what kind of epithelial cells would be there?
Simple.
Yeah, simple pancake. Simple squamous epithelium is what this is. Simple squamous epithelium. It's pretty thin. But what you've done is cut the air sacs in the lung, and these are all parts of air sacs. Simple squamous epithelium. Now, what do kidneys do?
Filter the blood.
Filter the blood, okay? Kidneys are full of little tubules, So they're filtering the blood. That means they leave the red blood cells, they leave the white blood cells, they leave the platelets, and they just take out plasma. And they put it through the tubes, or tubules. So these are tubules, because you cut the kidneys, packed with these tubules. And what's the center of a hollow tube? Lumen, L-U-M-E-N. The lumen is the center, L-U-M-E-N. So these tubes would have filtrate, the liquid flowing through them. Kidneys filter the blood, so the plasma filtrate would run through them. All right, so these cells have nuclei kind of in the center. So what would you call them? Cuboidal, simple cuboidal, that's right. They're not stratified. They're simple air with a lumen. They're around the lumen, okay? Simple cuboidal epithelial cells, okay? Let's drop down. Down here, they're not cuboidal, they're what? Columnar. See how the nuclei are down towards the bottom? Okay, and they look like columns. And they look fuzzy up here. What's that? I'll tell you, it's not cilia, you first thing. They're microvilli, fuzz. And so what would it do? Absorb. So where are we? Small intestine, absorbing the digested food. They're great for that because they have the microvilli.